Hello and welcome to Inaport Training. In this session we're going to show you how to use Inaport to build a relationship tree with inside GoldMine. Relationship trees can be extremely useful. As you can see from the screenshots at the right, the top screenshot shows a company and then divisions within that company and then contacts within the divisions. Very simple, straightforward and clear way to show the relationships of the people within inside that company. We've got a slightly more complex example underneath that. We've got the company at the top and then we're splitting the divisions down within states. So we're showing the state of New York, state of California and then the divisions within that, which provides us with more information. The problem is that building that kind of multi-level tree can be very difficult inside GoldMine. GoldMine does provide very simple support for building single level trees, but no support for building more complex structures such as the ones we're more likely to want. Complex trees need to be built manually, which is a very slow process, it's very error prone, and it's very difficult to update and change because you're relying on users to remember to make changes whenever anything changes in the database. Inaport provides you with a relationship tree builder, which allows you to firstly design or model the tree that you want to build, and then preview that tree using real data from your GoldMine system, and you can preview with 10 records, 100 records, 1,000 records. Once you're happy with the model, you can then build the tree inside GoldMine, and you can automate the process so Inaport can build and rebuild the tree as your data changes. The first step is to build a model of the tree that you need. It can be single level or multi-level. You have a what you see, what you get environment where you can drag and drop nodes. You can add and delete nodes at will, and you have a couple of different types of nodes to play with, break nodes and match nodes. Break nodes allow you to select distinct values, for example breaking on a company name. Match nodes allow you to see if a contact matches the requirements, for example the department is sales. We'll go into more detail on break nodes and match nodes further on in the presentation. You can see a couple of models in the screenshots below. On the left hand side you can see that we've got a break node on company and then state underneath that, and then match nodes on the department. So is it department sales, is it C-level? On the right hand side we've modified that. We've made the break node on the state at the top level and then company underneath that. So simply by dragging and dropping a node we've been able to completely change how we organize the data, and we can see the effect in the preview pane. We can use a SQL select statement to pull data out of our GoldMine system and then run that on 10, 100,000 records and have a look in the Inaport user interface as to how the tree is going to look. You can see on the left hand side we've got company at the top and then state and then department underneath that. On the right hand side we've got state, company and then the department underneath that. So we can look at the two models and decide which one we want to work with. Once we've done that we can build the tree inside the GoldMine environment, and then we can save the profile and rerun it on demand. So we can decide we can rebuild the trees once a week, or we can automate it using Windows Task Scheduler. We're going to move now to show you an example of using Inaport, and it's going to be slightly more complex than the one we've just been showing you. We're going to have a set of contact records in GoldMine that are property, unit and tenant, and the objective is to have property at the top level, unit underneath that, and then tenant underneath that. And you can see from the screenshot at right the end result that we achieve inside the GoldMine environment. For the purposes of this demonstration, we set up some contact records inside GoldMine. You can see that the contact records have set the key 1, key 2, key 3, key 4 fields. Key 1 is the record type, property, unit or tenant. Key 2 is the property number, key 3 is the unit number, and key 4 is the tenant number. Obviously you're not restricted in how you set up the fields. Let me move across to Inaport and give you a demonstration of how this works. You can see now on the Inaport screen the wizard that's used for building the relationship tree builder inside Inaport. First step is we say what data do we want to get out of GoldMine in order to build this relationship tree. And we can do any SQL statement that works for the data that we want. The only requirement is we do have to select the account no value because that's used by GoldMine for linking the contacts together. In this case we're selecting the account no, company, contact, phone 1 and address 1 because we're using that data to display in the tree, and then key 1, key 2, key 3 and key 4 because we're using that data to structure the tree. We're pulling that out of contact 1. We don't have to pull it out of contact 1. We can actually build any SQL statement that joins together any set of tables inside GoldMine. So we can, for example, build relationship trees based on detail records or history records. And finally, we're saying where key 1 is property, unit, or tenant. So we're restricting the set of records that we want to pull out of the GoldMine for the purposes of building this tree. Once we've done that, the second and most important step is actually building the model of the tree. You can see on the left hand side that we have a model of the tree that's specifying what type of node is going to apply at each level. For example, at the top we've got a break on the key 2, which is the property number. Underneath that we've got a match node that's saying we only want to move the record down if the key 3 field, which is the unit number, is not blank. In other words, if this record is a property record, we only want to display it at the top level. We don't want to display it any further down in the tree. Underneath that, we've got a break on the key 3 value, which is the unit number. So we're going to wind up with a top level node, which is the property number. Underneath that, a set of nodes that are the units that belong to that property, and then we're going to display the contacts underneath that. Over on the right hand side, you can see that down the bottom we've specified what we call a leaf expression, which is saying when a record makes its way all the way down the tree to this point, how do we want the data displayed? Once we've done all that, we go to the preview pane and click Build Preview, and we can run this model on as many records as we like. In this particular case, we've only chosen 10 records out of the GoldMine database based on the SQL select statement, and you can see that we've been successful in building the top level property as Hogwarts. Then we've got a match node for units, and so these are the units that belong to Hogwarts, and we've got Gryffindor Tower, Hufflepuff, Ravenclaw, and Slytherin. And then finally we have the tenants underneath each of those units. Final step of the wizard is job control, which is where we specify, for example, log file or job chaining. So these are used when we're automating the process. The log file gives us detailed information about how the run went, and job chaining allows us to set up multiple Inaport jobs, and we can move from, for example, importing accounts and contact information out of our accounting system into GoldMine and updating GoldMine, and then chain to rebuilding the relationship trees using the new information we've just imported. If we now move back to GoldMine and have a look at the relationship tree that got built, you can see, apart from some shortages in the GoldMine user interface, you can see that we've got the manager in there, we've got the units, we've got Gryffindor Tower with Harry Potter, and all the other details. Well, now we're going to move back and explain a little bit more detail about the how these trees are built. As you saw from that example, tree model is built from a set of break nodes or match nodes. At runtime, when a record is read from the database, it works its way through the model, and the record is evaluated at each node to decide what's going to happen. A break node will create a new physical node in the tree for each distinct value of the node expression. A typical example here is using the company name or the state name. A match node is very different. It operates like a filter, deciding whether the record should be passed down to the nodes underneath it in the tree, or whether it should be stopped, in which case it moves on to siblings in the tree. Looking at this in a little more detail, if we look at a break node, you can see on the left hand side a screenshot that shows the model that we built, and you can see that the second level had a break and the value of the break was the state field. On the right hand side you can see the result of that in building the physical tree. So you can see that we have a company node, Acme Corp, and then we have two state nodes. We have a state node for New York and a state node for California. A match node operates very differently. You can see that a match node always creates a node in the tree, and then we decide whether the record is going to get placed under it or not. So we create a node called sales, and then underneath that we put any records where the value of the department field is sales. We also create a node called C-level, and we put any record that has department equals C-level underneath that node. For each node, the node label expression controls how the node is shown in GoldMine. So on that break node state, the label expression was actually state concatenated with the value of the state field, and you can see the results in the tree. The other thing that can happen is we generate leaf nodes. A leaf node is when the record is moved as far down the tree as it possibly can, so it's actually placed there. And typically you're going to want something like the contact name when we put it in the leaf node. So you can see here that the leaf node expression was just the value of the contact field, which gives us the name of the contact, Michael Jones or John Smith. The trees can be based on any SQL select statement that includes the account no field. So for example, we can select contact 1 and contact two user-defined fields. We can select detailed records from ConSUP, or we could select opportunities and use any combination of those to build the relationship tree. This gives you enormous power and flexibility in building different types of trees. I hope you found this presentation useful. For more information, please don't hesitate to contact Inaplex on the email address or the phone numbers below, or you can go to our website, go to our YouTube channel for more tutorials such as this, or you can go to our forums to ask questions. Thank you and have a good day.